Math 1314, Section IC1, Spring 2022, Tyler Junior College. Section 4.7, Equations in Quadratic Form. Video 3, one more example of solving an equation that is quadratic in form. This is really not that much different than the previous one, except after we finish using the substitution, what we have left, it requires a little bit more work, but nothing that you're not capable of handling. For example, we're going to solve the following equation. Open parentheses, w squared minus 5w, close parentheses, squared, minus 2, open parentheses, w squared minus 5w, close parentheses, minus 24 is equal to 0. First, notice that this equation is quadratic in form because it contains the same expression twice, once with the second power, once with the first power. The second power being here, I'm about to circle in red. And the first power being implied right there. That's the criteria for being quadratic in form. Same expression twice, once to two powers. One power is twice the other, the simplest of which is second power and first power. When this is the case, then you can make a substitution to change it to a legit quadratic equation. So we're going to start by letting u equal the part in parentheses, which is w squared minus 5w. Then that gives us the following equation. Let's clean this up here for a second. The part that is, the part in the parentheses, the part that matches everywhere, the w squared minus 5w, all of those will become the letter u. So everywhere in the top equation where there is a blue rectangle, I'm going to draw u. So we'll get u squared minus 2u minus 24 is equal to 0. I don't like this color of blue. Give me 1 second to change it to a darker blue color. There we go. All right, now we have our quadratic equation. I am going to solve this one by factoring. You're welcome to use the quadratic formula, but factoring is so much faster, when it can factor and you are capable of factoring it. This will factor into, well, I need two numbers that add to give -2, but multiply to give -24. I think I need some flavor of 6 and 4. If I put a negative on the 6 and a positive on the 4, those add to give -2. They multiply to give -24. Those are the correct factors. And now that it's factored on one side and equal to 0 on the other side, we can split this and set each factor equal to 0. So we have u minus 6 is equal to 0. And we have u plus 4 is equal to 0. Both are pretty easy to solve. If we solve u minus 6 equals 0, we get u is equal to 6. And if we solve u plus 4 is equal to 0, we get u is equal to -4. But we're not out of the woods yet, because remember, we're solving for w. We removed the w and replaced it with a u, or removed an expression with w and replaced it with a u to make it easier equation to solve. We solve the easier equation. We know what u equals. Now we have to turn the u back into what it was holding the place of, which was w squared minus 5w. So on the next screen, I'm going to take these two equations and rewrite them where I change the u back to w squared minus 5w. All right. W squared minus 5w equals, and w squared minus 5w equals. I forgot what the two numbers were. 6 and -4. What this does is it gets the w back into the equation. And now we got to figure out how to solve this. Well, these are both quadratic equations in their own right. So we would get them both equal to 0 and do something. For the first one, if we subtract 6 from both sides, we'll get w squared minus 5w minus 6 is equal to 0. Let's go ahead and solve this one. open up parentheses to try to factor it. Feel free to use the quadratic formula. To factor it, I would put W's in the front of each parentheses. And now I look for two numbers that add to give -5, but multiply to give -6. I'm sorry, folks. Those two numbers are -6 and +1. They add to give -5, multiply to give -6. Now that our equation is factored on the left and equal to 0 on the right, we can split it by writing each factor equal to 0. W minus 6 is equal to 0. W plus 1 is equal to 0. And solving those gives us W equals 6 and W equals -1. But we're not done, because that was only one of the two equations. We just solved W squared minus 5W equals 6. We still have to solve W squared minus 5W equals -4. But we'd solve it the same way. Get it equal to 0 by adding 4 to both sides will give us W squared minus 5W plus 4 is equal to 0. I'm going to factor. You can get out the quadratic formula. W at the beginning of each factor. And now we need two numbers that add to give -5, but multiply to give +4. Those two numbers would be -4 and -1. It is now factored and equal to 0. So we set each factor equal to 0 and get W minus 4 equals 0 and W minus 1 equals 0. Solve those pretty easily. For the first one, we would add 4 to both sides and get W equals 4. For the other one, we would add 1 to both sides and get W equals 1. And we have our solution. If this were a homework question, you would probably just type the 4 numbers separated by commas. All right, that's really all there is to say about equations that are quadratic in form. The trick is identifying when it's an option. And in homework 4.7, which only has 5 questions, all 5 of them are options. Replace the repeated expression with a U to rewrite the equation as a quadratic equation. Solve that to figure out what U equals. Once you've done that, bring back in the thing you took out and then continue to solve. The difficulty in these lies on how complicated the expression is at the beginning. In this case, the expression was W squared minus 5W. So when I brought that back in at the end, it created 2 quadratic equations. There are more complicated expressions. There are simpler expressions. You got a mixture in your homework. And that's the end of the videos in this series. If you got any questions, you know how to get a hold of me. You should know how to get a hold of me.